Let's finish with these last few distributive and commutative properties using exponents. So with this first one, where we're distributing an exponent, we're allowed to distribute exponents over multiplication or division. That's part of the exponent rules we learned in previous videos. So what I mean by distribute is that the squared goes to both factors. So in other words, this is the same as x to the 6th being squared and y squared being squared. And our rule of exponents was that we would multiply those exponents. If you're raising an exponent to another exponent, you multiply. So this would be x to the 12th, y to the 4th. Let's try this next one. In this one, we have an addition sign and an exponent. Those do not distribute. So exponents do not distribute over addition, subtraction. So this actually cannot be simplified. Later on in the course, we're going to learn a technique called FOIL. And in that case, you could FOIL this out and multiply it out, but that's not really simplified. That's actually more of an expanded form. So this is already considered simplified because exponents do not distribute over addition, subtraction. Well, let's look at this one. I changed it a little bit. What's different now is that there's an x. And as soon as I have that x there, now this is a multiplication. So I want us to look at the sort of intricacies here because all three of these look sort of similar, but we have to pay attention to when are we multiplying, when are we adding, when are we raising to an exponent, because that's different. So now that it's multiplication, I can distribute over addition. So this would be x to the 6th times x squared plus y squared times x squared. And these would simplify. We would add those exponents, and it'd be x to the 8th. And then these are not like bases, so we're just going to write them together, y squared, x squared. So hopefully we see the difference between those three examples. Let's try some commutative property. Commutative means we can flip the order. So we can change the order of multiplication in these examples, but it also works with addition. So what I mean by this is that in this case, I have 5x times 3y times 2xyz. It looks like three separate factors, but in reality, there's a lot of different factors here. The 5 and the x are two separate pieces. The 3 and the y are two separate pieces. The 2, the x, the y, and the z are really all separate factors. We don't, just because it was originally written as three factors doesn't mean we have to view it that way. Because they're all multiplied together, we can put these in any order we want. So what I want to do is join all the numbers out front together. 5 times 3 times 2. I also want to join all the x's together. X times x. And all the y's together, y times y, and then there's only one z. We'll just keep that one at the end. Now that we've rewritten it, it's going to be a lot easier to simplify. So 5 times 3 times 2 is 30, because 5 times 6 is 30. X times x is x squared, y times y is y squared, and then z. And we don't have to put the dots. You certainly can if you want, but writing these next to each other is the same as multiplying them together. So we don't have to rewrite it, right? I did that just to show me using the commutative property, but eventually we want to get to the point where we just say, oh, I can just multiply the 4 and the 6, right? Just because it's written like it's two separate pieces doesn't really mean it is. So the 4 times the 6, I feel like writing it out again. For my notes. If you don't need it, that's great. For my notes, I'm going to write it out. So I want to do the 4 times 6 first, and that's 24. And then x to the 4th times x to the 6th. Together that makes x to the 10th, because we're adding those exponents. And then y to the 6th. So we want to join the numerical coefficients, multiply those, and then multiply the x's together, multiply the y's together.